this section is going to be spent defining and working with slope. To find the slope from the graph of a line, we pick any 2 points on the line. From these 2 points, we construct a right triangle. From one point, we'll draw a line down and the other across until this triangle is constructed. This triangle can be above or below the line. This allows us to find a rise and a run of the line, and the ratio of rise over run is the slope. We can use any 2 points, but we want to pick points that allow for the most accuracy. Notice how I come down from one point and across from the other to form this right triangle. Once constructed, count the squares to represent the rise and the run. The ratio is the slope. Before we look at another example, we need to include more information with this discussion on slope. With this slide, we have 2 lines, one rising and the other falling as you move from left to right. We will associate climbing a hill as a line with positive slope. After all, it is rising as you move from left to right. If you are descending, this is a negative slope, since the line falls as you move from left to right. Here are our special cases. Can you ride a bicycle straight up a cliff? Obviously, this is not possible. Associate this situation with no slope or undefined slope. What about a horizontal line or a flat road? This is possible. Associate this with a slope of 0. Back to another example. When we draw the right triangle using 2 points on the graph, we can find out the magnitude or the number part behind the slope. This process does not include the sign. Therefore, we need to consider the sign of the slope, and if negative, we will need to get a negative attached to the slope. For this problem, I have drawn the triangle below the line again, because that seems to be what I prefer. Count the squares of the graph paper for rise and run. And again, don't forget to attach the negative since the line falls has negative slope. So far, we have looked at finding the slope graphically. The graphical method will work for us if the coordinates are all integers and smaller values. There will be times when we won't be able to find the slope graphically. So let's move on to find the slope using a formula. Notice how the rise is the change in the y's and the run is the change in the x coordinates. So instead of counting squares on the graph, we will be finding these numbers through subtraction. Notice the subscripts on the x's and the y's. These are there because the order in how we put the x's and y's into the formula is important. It will not matter which point is point 1, which point is point 2. I stack the points and I have the top point as point 2. Here is what is important. It doesn't matter which y I start with for the difference, but I must start with the x from that same point in computing the run. So as you can see, the rise is 4 minus a negative 2. The run is negative 5 minus a negative 1. Simplify and reduce this for your slope. Here's another example. Again, I will stack the 2 points. Doesn't matter which point is on top. Subtract the y coordinates with the same order as you subtract the x's. If you want reassurance, plot the 2 points. You'll be able to verify your answer by finding the slope graphically. Let's move on to a special case. Now, how do I know this is a special case? Look closely at these 2 points. The x coordinates are the same. If the x coordinates are the same, their difference is 0, meaning there is no run. We're trying to divide by 0, which we can't do. The slope is undefined. Here are the 2 points plotted. Remember the bicycle trying to go straight up the cliff? We said this is not possible. The slope for vertical lines is undefined due to the fact that there is no change in the horizontal direction, or there is no run. Here's another special case. This time the y coordinates are the same. This time the numerator is 0, which means there is no rise. What kind of line would not have changed in the vertical direction? Well, of course, a horizontal line. We did say a flat road would have a slope of 0. It works out this way mathematically as well. Let's discuss another arrangement of how to write an equation of the line. Here the equation is solved for y. if the equation is solved for y, the number in front of x is the slope and the constant is the y-intercept. This is the form that I prefer. With the other form, the standard form, the coefficients or constants don't have meaning. If we are asked to find the slope and the y-intercept, we need to get this equation in the slope-intercept form, which means we have to solve this equation for y. Now there is a bit of work to rearrange this equation, but understand it is the fastest way at arriving at this information. We start by subtracting 2x, then we are left dividing by -3. Make sure to divide each term separately by -3. Due to only one variable for this problem, this is a special case. This line will only cross the x-axis. It won't cross the y. Because this is a vertical line, there will be no y-intercept, and the slope will be undefined. Moving on to discuss parallel lines. As you can see with the sketch, parallel lines have the same slope. Perpendicular lines, on the other hand, have opposite sign for their slopes, and we also see that one line is much steeper than the other. To find the slope of a line perpendicular to a given line, change the sign on the slope and flip the number part. What do we have here? They're not parallel since the slopes are not the same. To be perpendicular, you would need to see reciprocals, which we do, but we would also need to see opposite signs on the slopes, and we don't. So this case is neither. Here we're asked to find the slope where x and y now have meaning, and because of this, we need to include the units on the rate of change or slope. With the two chosen points, there is a $9,000 increase over 3 years. After we divide, we see that we have $3,000 increase every year. So hopefully this presentation has been helpful. Review it as many times as necessary to be able to compute and understand the slope. And if struggling, please seek some help.